Okay, today this video we are going to discuss the diagonal relationship between boron and silicon. Okay, welcome to the new video session. Today we are going to discuss the topic diagonal relationship between boron and silicon. Okay, so S block elements case diagonal relationship diagonal relationship discuss lithium magnesium beryllium aluminum. Okay, so in this video we will discuss the diagonal relationship of boron and silicon. Both are in P block elements. Okay, so second period and third period elements in the similarities. Diagonal relationship, diagonal place second period and third period elements in similarity diagonal relationship. Okay, we will introduction to diagonal relationship. Okay, an element among the lighter elements, for example lithium, beryllium, borons, etc. of the second period resembles the elements of the third period placed diagonally to its right in the next group. This is called diagonal relationship. Diagonal relationship is second period lighter element second period elements in the similarity either third period right position third period higher element. That's the conditions these two elements diagonally place relation diagonal relationship. Okay, an element of the lighter elements of the second period resembles the element of the third period placed diagonally to its right in the next group. This is called diagonal relationship. Okay, then the cause of diagonal relationship, the reason for diagonal relationship. The cause for diagonal relationship can be explained as follows. We know that the atomic and ionic size decreases along a period and increases down a group. We have video atomic size and ionic size left and right along the period decrease top and the bottom atomic size and ionic size okay, that's why the electronegativity left and the right increase top and the bottom decrease. Okay, further the electronegativity increase along a period and decrease down the group. This variation are such that similarities occurs in these properties: atomic radius, ionic radius and electronegativity. Okay, so these similarities the variation are such that the similarities occurs in these properties such as atomic radius, ionic radius and electronegativity. This variation is diagonally placed lighter element ionic radius, atomic radius and electronegativity similar right. Okay, the variation are such that the similarities occurs in these properties: atomic radius, ionic radius and electronegativity among each pair of diagonally placed lighter elements of the second and third groups. Okay, then similarly also occurs in the polarizing power of the cations. Okay, so polarizing power of similarity is diagonal elements. Okay, similarly also occurs in the polarizing power of the cations. This in turn causes such a pair of elements to have several similar physical and chemical properties. Thus, lithium resembles magnesium and beryllium resembles aluminum and boron resembles silicon in several properties. Okay, next we are going to discuss the diagonal relationship between boron and silicon. So, boron and silicon okay. Then boron shows diagonal relationship with silicon. Boron shows diagonal relationship with silicon of group 14. Boron shows striking similarities with silicon in properties. Some points of similarities are mentioned below. Okay, so boron is the 13th group, silicon is the 14th group. These two groups elements similarities. Okay, the properties first. boron and silicon exhibit the typical properties of non-metals. Okay, boron and silicon are non-metal character. Okay, boron and silicon exhibit the typical properties of the non-metals. Okay, then second properties, neither boron nor silicon occur in the native or free state. Both occur at their oxo compounds. Example, borate and silicates. Okay, both silicon and boron occurs in nature as a borate and silicates. That means the oxide form. So boron and silicon oxide form is natural and free state. Okay. Then third property, boron and silicon have similar densities, electronegativities and ionization enthalpy. Okay, is a interesting property. Boron and silicon have similar densities, electronegativity and ionization enthalpy. Okay, similar, right? Another property, both of them do not form cations. Both boron and silicon do not form cation. Cation means positive ions. Both form covalent compounds like hydrate, halides and oxides. Both boron and carbon forms covalent compounds like hydrate, halides and oxides. Okay, then next, both boron and silicon exist in amorphous as well as crystalline forms. Both boron and silicon exist in amorphous as well as crystalline forms. So boron and silicon compounds amorphous state exist and crystalline state exist. For each, the crystalline forms is harder and less reactive than amorphous forms. Okay, crystalline forms are reactive than the amorphous forms. Okay, then next property, both boron and silicons are not attacked by water or non-oxidizing acids. Both boron and silicons are not attacked by water or non-oxidizing acids. Okay, then next property, both boron and silicon can be prepared by reducing their oxide with magnesium. Both boron and silicon can be prepared by reducing their oxide with the magnesium. The reaction of B2O3 plus Mg plus 3 Mg gives 2 boron plus 3 MgO. Okay, that is boron preparation. Boron oxide and magnesium react with we will get boron. The next reaction, okay, SiO2, silicon oxide, react with magnesium to give Si plus 2 MgO. So silicon can be easily prepared by reacting with magnesium. Okay, the next property, both boron and silicon react with oxygen at a higher temperature to form corresponding oxide, B2O3 and SiO2 respectively. Okay, so boron and silicon oxygen at higher temperature react with we will get the corresponding oxide. Okay, for boron plus 3O2 gives 2B2O3 and Si plus O2 gives SiO2. Okay, the next property, both boron and silicon combine with the sulfur at elevated temperature to form their sulfides. Okay, both boron and silicon combine with the sulfur at elevated temperature to form their sulfides. So, this boron and silicon sulfide react with the sulfide form. For example, B2S3 and SiS2 respectively. The reaction, okay, 2B plus 3S gives B2S2. Boron sulfide, then Si plus 2S plus SiS2, silicon sulfide. Okay, the next property, both boric acid B2O3 and silicon SiO2 have higher melting point and are acidic in nature. Okay, both boric acid and silica have higher melting point and are acidic in nature. They dissolve in alkali solution to form metaborate and silicate respectively. Okay, both boric acid and silica have higher melting point and are acidic in nature. So, this acidic nature is alkali easily dissolved to form their metaborate and metasilicates. The reaction of B2O3 plus 2NaOH gives 2NaBO2 plus H2O. That means NaBO2 means sodium metaborate. Other SiO2 hydrolysis, NaOH presence hydrolysis, SiO2 plus 2NaOH gives Na2SiO3 plus H2O. That means sodium metasilicate. Okay. The next property, the chloride of both boron and silica get hydrolyzed by water to orthoboric acid and orthosilicic acid respectively. Okay, the chlorides of both boron and silica get hydrolyzed by water to orthoboric acid and orthosilicic acid respectively. Reaction okay, BCl3 plus 3H2O gives H3BO3 plus 3HCl. That means orthoboric acid. Then SiCl4 plus 4H2 gives H4SiO4 plus 4HCl. That is orthosilicic acid. അപ്പോൾ ഈ ഓർത്തോബോറിക് ആസിഡും ഓർത്തോസിലിസിക് ആസിഡും ഉണ്ടാക്കാൻ വേണ്ടി നമ്മൾ എന്ത് ചെയ്താൽ മതി? ഈ ബോറോൺ ക്ലോറൈഡും SiCl4ഉം വാട്ടറായിട്ട് റിയാക്ട് ചെയ്താൽ മതി. അപ്പോൾ രണ്ടും ഫോം ചെയ്യുന്ന അതിന്റെ കറസ്പോണ്ടിങ് ആസിഡ് ഫോം ചെയ്യും. അപ്പോൾ രണ്ടിന്റെ സിമിലർ പ്രോപ്പർട്ടീസ് നമുക്ക് പറയാൻ പറ്റും. ഓക്കെ, then next property, the fluorides of both boron and silica get hydrolyzed by water. BF3 yields orthoboric acid and fluoroboric acid, while SiF4 yields orthosilicic acid and fluorosilicic acid. ഓക്കെ, അപ്പോൾ എന്താ പറയുന്നതെന്ന് വെച്ചിട്ടുണ്ടെങ്കിൽ ഈ ബോറോണിന്റെ ഫ്ലൂറൈഡ് അതുപോലെ തന്നെ സിലിക്കണിന്റെ ഫ്ലൂറൈഡും ആരായിട്ട് വാട്ടറായിട്ട് റിയാക്ട് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് അതിന്റെ ബോറോണിന്റെ കേസിലാണെങ്കിൽ ഓർത്തോബോറിക് ആസിഡും ഫ്ലൂറോബോറിക് ആസിഡും, ദെൻ സിലിക്കണിന്റെ കേസിലാണെങ്കിൽ ഓർത്തോസിലിസിക് ആസിഡും ഫ്ലൂറോസിലിസിക് ആസിഡും കിട്ടും. റിയാക്ഷൻ നോക്കുക, BF3 plus H2O gives H3BO3 plus HBF4. Okay, H3BO3 means orthoboric acid and HBF4 gives fluoroboric acid. Now SiF4 react with water to gives H4SiO4 orthosilicic acid plus H2SiF6 fluorosilicic acid. Okay, that's about the diagonal relationship of boron and silicon. Okay, thank you.